Let's move to the last presentation by Marshall Burke from Stanford called Climatic Constraints on Aggregate Economic Output, and it'll be a discussion by Paulina Oliva from USC. Marshall.
Great. Thanks, Rémi. Thanks for having me, and thanks for everybody sticking around through the end here. Let me share. Excellent. So I want to think about the aggregate impacts of warming here and do as good of a job as we can just with the bare-knuckled empirical evidence. This is not going to be a fancy spatial model. Hopefully what comes out of the work like this can get stuffed through one of the fancy spatial models that you've seen earlier in the day. I'm not smart enough to do that, so I'm going to just try to tell us directly what the data say. Thanks to a bunch of folks on this, including Saul, who's worked on this in the past. So I think as Saul and other folks have set up at the beginning, we know a lot at the micro level now about how changes in climate, past and potentially future, might affect fundamental building blocks of the economy. Saul showed a few of these results. Here is just proof by intimidation showing you a lot of these different ones. These are well-identified micro-level studies of, again, how various outcomes that we care about in the world at the micro level respond to, in this case, warming. So agriculture is well studied, labor productivity, cognition in terms of test scores, how we use energy, homicide, suicide, and the list goes on and on. Saul's Climate Impact Lab is pumping out one of these a week, basically at this point. We just have a really rich understanding at the micro level. But of course, the key question is how these effects aggregate, right? So we have great micro level evidence. How do we think about adding these things up? So one is just a simple bottom-up approach. So we go sector by sector or building block by building block. We try to dollarize the impacts and then we add them up, right? And we can either just add them up directly or we can add them up through the lens of a model. Both approaches have been taken. But there's also another approach. We could actually just let the economy do the adding up for us. That in some sense is simpler. We don't have to take a stand on how these things add. We don't have to take a strong modeling stand on how to do it. You just let the economy do it and you study the aggregate outcome like GDP, right? So the disadvantage, of course, is there's a lot of stuff that's not in GDP that we care about, mortality being the main one. But again, it has this benefit of having made a lot of the adding up decisions without us having to impose those. And this is important because we tend to push these aggregate results or these aggregate, what we call damage functions, the relationship between warming and changes in global GDP or global welfare. We push these pretty hard. So here are three that are well known and that have been pushed very hard in the literature in what's known as integrated assessment models. I assume most folks are familiar with this. The big three here are Dice, Page, and Fund. Dice is Nordhaus's model, won the Nobel on this. Again, these have been around for decades now and have been used a lot. More recently, there have been many complaints about their empirical foundation. Here are two quotes at the bottom. Bob Pindyke really doesn't like these. They are completely made up with no theoretical or empirical foundation. That's probably a little strong. Other folks, again, a few years ago, the models should be revised more frequently to accommodate scientific developments, to actually learn from all the micro level or potentially macro level well-identified studies that we have. So we're going to try to do this top-down, but using empirical data that we have available. So this is now work from a few years ago, just to set up then the subnational stuff I want to talk about at the end. So we have country-level GDP data. We have this back half a century. We observe annual temperatures. And we can relate one to another in a panel setting in which we think we can plausibly isolate the impact of temperature or precipitation from all of the other things that might affect how quickly economies grow. So on the left-hand side of this regression is growth in per capita GDP. And on the right-hand side is sort of whatever flexible functional form you want for temperature and precipitation, and then controlling for a bunch of fixed effects and local time trends that, again, the goal of which is to isolate fluctuations in temperature from all the other things that affect the outcome here. Okay, so again, this is using within country variation over time. If we estimate this thing non-linearly, again, as Saul pointed out, this allows the within country effect to depend on the average temperature, right? So if I estimate a nonlinear response in temperature, that allows the marginal effect of warming to depend on the average temperature of the country, and that turns out to be important because indeed what we find is a nonlinear effect. So again, this is a result from an earlier paper a few years back now. This is the global nonlinear effect of warming temperatures on growth in GDP. And as you can see, you can estimate this much more flexibly. It turns out it's fairly well summarized by a quadratic. And if you take the mental derivative, that gives you the marginal effects. The effects are positive at quite cold temperatures, again, consistent with a lot of the evidence you've seen already today. And then since this is a conference, a workshop about development, often we care about the hotter, so temperature here is on the x-axis. Hotter countries are well out here on the x-axis. Indonesia, India, Nigeria, Brazil, these are all countries, above 20 degrees Celsius average temperature. Here, the effects are robustly negative, the marginal effects. So additional warming, historical evidence tells us, leads to lower than average growth rates for these countries. Okay, so global nonlinear response. You can do a lot of things with the national level data. Just focus on the two top plots here. One thing is we can ask questions about, do we see differential responses in rich and poor countries? Again, testing a conventional wisdom that is heard a lot, that somehow wealth insulates you from the effects of climate change. Here, the data are a little noisy. We see, again, if you look in the top left here, we see what looks like a nonlinear response in both rich and poor countries, perhaps slightly flatter in rich countries, although these are actually not statistically distinguishable. The data are just too noisy. I'll come back to that in a moment. The other thing you can do is if you have strong priors on adaptation, you might expect that this relationship is going to flatten out over time as we learn to deal with the effects of hot temperatures or as economies develop. And we see absolutely no evidence of that, right? These two response functions, if I split my sample into an earlier period and a later period, they look almost identical, right? So at least on the face of it, no clear evidence of adaptation over time. Okay, now if we take that historical response function and heroically run it forward into the future and say responses to future warming, to future mean warming, and this has already been alluded to, look like how economies have responded to warming in the recent past, and just walk everyone forward on that response function I showed you, you get results that look like what's shown on the map here. You get very negative effects in the tropics, so up to 50% loss in GDP per capita relative to a world that didn't warm. This doesn't mean these countries are 50% poor relative to today. It means they're 50% poor relative to where they would have been without climate change. And most of the world suffers, but then in the higher latitudes in the colder parts, you actually estimate, at least with this model, pretty substantial benefits to the Scandinavians, to the Canadians, and to the Russians. But most countries in the world are worse off, at least in relative terms. If you aggregate this up globally, here's a plot from a paper again a couple years ago, and just think about what's the global impact. So on gross world product here, if I can use that term. So even if we keep the world to about 3 degrees Celsius, this would suggest we're going to be about 25% poorer than we would have been had we not warmed, right? So if you go back then to the IIM damage estimates that I showed you before, that is an estimate that is 5 to 10 times larger than the estimates currently used in those damage functions, again, in our benchmark integrated assessment model. So 5 to 10 times larger if you just take recent history seriously and you heroically run the world for it. Now, of course, there's a lot of assumptions baked in to that exercise. So can this be right? Some common complaints. One is about adaptation. Come back to that. Second complaint here, so adaptation is not listed here, but think of that as 0. Number 1, maybe we're not convinced this is actually a growth effect. I was running a regression of growth on levels in temperature. Maybe this is not growth. Maybe you're just picking up level effects, and so it's not reasonable to project forward in terms of growth rates. Some people don't trust national accounts data. What I just showed you has this whiff of cross-country growth regressions that we decided to abandon back in the early 2000s. Now, we think these are better identified, but maybe you still have fundamental concerns about the national accounts data on which they're based, potentially legitimate. And finally, countries are big, right? I think Nina just pointed this out, right? There could be a lot of differences within countries that we might care about that are not going to be picked up in this country level regressions. Okay, so let's try it with subnational output data. So working with an excellent RA who's now at University of Chicago and at Harris doing his PhD. we put together all the subnational, and so this is district level output data we could find from around the world. We don't have large parts of the world. We don't have anything from Sub-Saharan Africa, unfortunately, but we do represent much of the world's GDP, much of the OECD. We have China, we have India, we have Indonesia, Brazil. So it's not just the wealthy world. And what's good is most of the data we have come from countries whose statistical capacity, as estimated by the World Bank, tends to be pretty high. These should be places that collect high quality data on output. So instead of running what I showed you before at the national level, I'm going to run it at the subnational level using a very similar statistical approach. We can push these data pretty hard, including using, if you're worried about time varying stuff, we can use state by year fixed effects. So these are admin 2 data. If you're used to working with spatial data, I can include a time fixed effect at admin 1 level. So really controlling for local level time varying unobservables. And then a standard district fixed effect here. Okay, so what do we see? We see a relationship that you sort of blur your eyes, looks a lot like what we saw before. The left has the confidence intervals, the right, we can run this with many different climate data sets. We can run it as flexibly as you want. And this feels or is pretty robust. The estimated optimum, so where this thing sort of tops out, it actually is a little bit cooler than what I showed you before. That has implications for, so that means more countries are on the downward sloping part of the response function, negative marginal effects. That has implications for warming. Come back to that in a second. Oh, come back to it now. Here's the map. Take the mental derivative, plot that mental derivative on a map for all admin 2 locations in the world, and you get a map that looks like this, right? So again, this map has the flavor of what I showed you before, but more countries are in the negative red area. More countries see negative marginal effects from immediate increases in warming. So before it was like 75%, now it's something more like 90% of the countries in the world are harmed by warming. Okay, are these actual growth effects? So since Del, Jones, and Olkin from a decade ago now, the way we think about growth effects in the empirical data, or the way we estimate them, is to estimate these distributed lag models and add up the lags. We can also estimate a long difference model. That is not shown here. Both are ways to think about, are we picking up sort of persistent effects of temperature on output? So the no lag model is shown here on the left. If I add a bunch of lags, this thing actually gets a lot steeper. So to us, this is pretty strong evidence that we are indeed picking up growth effects and not just level effects. I will tell you that the long difference estimate is even steeper than the 5 lag model, what's shown here in panel B. And you get effects in that estimation that are almost implausibly large, if we're being honest, but that's what they are. So
Marshall,
it does appear to be growth effects. And finally, using the subnational data, thanks, Rémi, I'll be done in 3 slides. We can do a little more to try to understand whether wealth is a mitigating factor in terms of the impacts of climate change. So will development save us? Will wealth insulate us from the effects of a warming climate? So using the variation we have, I can divide units into quintiles, or do this however you want, whatever quantile you desire, and estimate quintile specific, so quintiles of income, right? Quintiles of income across the sample. And estimate quintile specific responses, see if this effect of temperature on the growth rate differs by quintile. There is some noise here. I didn't plot the confidence intervals. They're wider than I would have liked, but the marginal effects across all the different quintiles at a given average temperature are not statistically distinguishable again. So again, no smoking gun evidence here. There is some noise, but no smoking gun evidence that wealth is somehow insulating or that development is going to save us from these impacts. Another way to quickly look at that is we can just run the USA by itself. I can just run this regression in the US, and I can compare that to the pooled response I get when I use all of the data that I have, and I get a response function that looks almost identical, right? So I take the wealthiest country in our sample, I run the same thing, same regression, just on that country, I get the same response, right? So another piece of evidence that wealth is not obviously insulating from these effects. Okay, let me wrap up quickly, Rémi. I'll give you back 3 minutes here. So in both the country level data and in the subnational data, we see what looks like a nonlinear effect of temperature on historical output. This thing gets steeper as countries get warmer, and so the tropics, all these data would suggest are going to be hit the hardest. So that's a very important development story. We do not see strong evidence that the structure of the economy or the wealth of the economy mitigates these effects. We don't see strong evidence of adaptation over time. This nonlinear response has not flattened over time in a way that clearly suggests adaptation. And again, we see a fairly similar response in national and subnational data. And we think pretty strong evidence for growth effects, especially in the subnational data, when you get this very robust nonlinear response when you add a bunch of lags to the regression. Okay, again, so if you run the world forward under this response function, we can talk about the assumptions necessary to do that. You get a very high likelihood of substantial losses, certainly in the tropics, but also globally under future climate change. And these are a lot larger than what's baked into the current damage functions in integrated assessment models. And so I guess my final sort of conclusion here is I think we ignore these large aggregate impacts at our peril. I think, there's still some unanswered questions. And I think as Saul alluded to early on, we don't understand fully what's going on under the hood. We don't have a great way right now to map the micro level estimates that I showed at the top here to these large macro level effects. And so being able to do that in a convincing way is perhaps key to believing these results. But I think we ignore the aggregate stuff at our own peril, right? This is robustly in the data and in various ways of looking at the data. And so my argument would be that micro-founded estimates that don't match these macro moments, if we do this adding up and we don't get back to macro level effect, I think we should be worried about that, right? I think it might mean that we are missing something in how we add things up. And so we should take these aggregate results seriously. So I will stop there, and thanks very much for having me.
Great, thank you so much. Now we have a discussion by Paulina Oliva from USC.
Great. Well, Marshall, this was a pleasure to read this paper, and thank you so much for inviting me to discuss it. It's super exciting to see this data becoming better and better, and I guess that's sort of my first comment. I'll give a quick summary of the comments because we have such limited time, and then I'll try to go into a little bit of detail on some of them. It's great to have this data. I agree that I think getting at the subnational level, given how much variation in temperature we have within countries, is critical for us to be able to learn more about this aggregate effects of climate change. So I'm very excited to see, I think that there's going to be more than one paper written with this data. So I'm really excited to see what it produces. You alluded to this at the beginning and alluded at the paper. I mean, at the minute I saw this very specially disaggregated paper data and you, in one of the graphs when you were talking about what's happening at the subnational level, you kind of alluded to the fact that having linkages within a country could protect districts from some of these effects. And I think this would be a very exciting direction to take this data with, and also kind of, thinking about the previous paper that got presented, but now at the subnational level, and trying to learn about, how much being within the boundaries, right, of a given country can protect you from some of these climatic events, how much kind of barriers to trade are going to matter here. So I'd be very happy to see this direction at some point being developed. Now, in terms of the comments that I had, I think the direction where you're taking this is exactly the right one, and trying to learn more about what's happening in the short run with short run variations in temperature and comparing it to the long run differences. But I was wondering if with the given specifications that you have, these comparisons are coming through. In particular, what I would have liked to see is a panel specification that to some extent includes some of the long run effects that are happening at the local level, and compare that with the long difference, so that we can learn what's happening in the short run and what's happening in the long run. I worry that with the state year fixed effects in the panel, you're losing important variation in temperature, and I'm not entirely sure what is the endogeneity you're concerned with in the absence of this fixed effect. So I'll try to get into details in a second. Now, one of the main takeaways, which I think you can totally get to, but I think that I'm not quite convinced yet, but shedding light on the specific issue of whether income is going to save us, I think it's great. I would very much like to see more on this. As it is, I don't think the evidence is quite as strong. It kind of relies, in my view, too much into that comparison of the U.S. versus the rest of the world. And I think you can do a little bit better at this. My last kind of big comment is on the long difference methodology that you used. It's unusual. It's different to what you used before in other papers. And I had some comments on it. So let me see if I can get to them, because I think it's good to innovate, and I think you're up to something. But I had some concerns. All right. So let me just talk a little bit about this panel specification, which is what you're running here. So the first kind of function here is the nonlinear function of temperature. You're controlling for district fixed effects, which I think it's appropriate to learn about these short run variations. But then you're also introducing this term, state year fixed effects. So when I was thinking about this, and this is now just kind of taking advantage of variation within a state across districts. So then the remaining variation in temperature, once you control for this, is going to be driven by geographically large states, right? So, that kind of limits the amount of representativity, right? We have a lot of representativity in the original sample, but once you throw in the state time fixed effects, then you're going to narrow that. So, that concerns me. And then, also importantly, the estimated response function is going to exclude these long run changes that are going to be correlated within state. So that, to me, it's going to make it hard to compare what's happening in the short run and in the long run. So I was just curious about what is the endogeneity that you're trying to absorb here. I mean, in my mind, temperature is, it's coming exogenously to us. So I'm just curious about what's the endogeneity that are you worried about here. I understand, obviously, why you would want to include the district fixed effects. We think that, if there's, these are going to capture a kind of more state of the world type of variables that can affect, that could be related to cross-sectional variation in climate. But I didn't quite see the big argument for using this state level time variation. So then this is sort of my point on the comparing, trying to think about whether income is going to save us. When I first looked at the graphs, and then I looked at how you had interpreted. And when I look at this first graph, I had sort of concluded the opposite to what you did, which is I did see some of these kind of relationships varying across quintiles. Then I saw that in the robustness checks, you have this is not very persistent across the different specifications, and I understood why you concluded that. But I think, there's no strong evidence either way, and I would like to see a little bit more of a stronger evidence either way, and whether income is going to really make a difference. I mean, we have other papers in the literature that show there's evidence consistent with that. So I think, it would be good to shed more light on this. So then let me just go a little bit with the long difference regression that you have. I mean, I sat and thought hard about it for a while, and a way I could make sense of what you're trying to do is the following. So imagine that we have income being run as a function of quadratic temperature, but thinking, this is not the income that you have, but the GDP that represents the long run fundamentals as a function of temperature. So this is going to be not the income that responds to short run fluctuations, but more on the fundamentals. If I took the derivative with that with respect to time, right, then I would have the trend, which is what you're trying to run as a dependent variable, the trend of income, right, which is you denote as this, being run as a function of a trend, being regressed as a function of the trend of temperature. But then, if you take the derivative with respect to time, you end up with this term here, right? Which is giving you the trend of temperature, right, interacted with the level of temperature, which makes sense because this is telling us that long run growth responds to long run changes in temperature depending on the level or the baseline of temperature, right? What you have in the regression is slightly different. So you have this term, right, that is obtained from a first stage regression of output on a time trend, right? So to me, it's capturing this derivative with respect to time, right? you run it as a function of the derivative of temperature with respect to time, which to me it's capturing this term. But the second term, I just couldn't make sense of it. So the second term comes from the derivative of the square of temperature with respect to time, right? Which, you know, I was expecting something like this, and that's not what you have. So, you know, just a suggestion that maybe something closer to this is what you need here. Let me just kind of give you a couple of more comments. So I had trouble understanding the calculation of the panel effect in order to compare it to the long run effect. Just how you demean it, you trend it, and in order to compare it. And I had in my mind this recent paper by Ashwin et al. With long list of co-authors in Nature that shows that income is a key determinant of energy consumption in response to warming. And I was curious of why can't we see this in the GDP data? Thank you so much.
Great, thank you. People who want to leave, you should feel free to leave, but Marshall, it's up to you if you want to take the 5 minutes to respond or like get more comments from the audience.
Okay, thanks a lot. Paulina, thanks. Those are really useful comments and a lot to think about, so I really appreciate it. I'll just take any other comments if folks have them. Otherwise, I can respond quickly or let people go. I know we're at time.
Marshall, I had a quick question, if you'll indulge me. When
Yeah.
you were making statements about adaptation, I think there are two notions of adaptation happening here. So one is sensitivity in your regression to the idiosyncratic variation that's year to year. And then when we were having the policy discussion earlier, I think people are talking about adaptation as like investments that are targeting the trend. And so it's not clear to me that like if I have this forecastable trend of stuff and I'm going to make investments to respond to permanent changes, it's not clear to me that would reduce my sensitivity to the idiosyncratic year-to-year variation. So I wondered if you could comment more about, you know, what kind of, when you say we don't see adaptation because the sensitivity to the idiosyncrasies is as strong in recent years as it was 30 years ago, it's not clear to me that what that says about adaptation to permanent changes.
Yeah, that's right. I mean, this is one of the fundamental, I think, empirical questions in this literature. What do we learn about adaptation, and what are we picking up about sort of longer run effects, and when we run these responses, these what look like shorter run responses? Yeah. For that reason, I really like the long differences sort of approach, because it at least more plausibly is looking at the sort of longer term, slower moving changes that we think we're going to be exposed to in the future, right? So basically what it requires is that looking backwards, we have what it requires to tell us, I think, something about how people respond to longer term changes in temperature, is that looking backward, we have variation that looks like what we might see going forward in terms of decadal changes, right? And so one way to answer your question is just to appeal to the long differences. And when we run that, subject to, I think, the concerns that Paulina had, and Paulina, we have struggled over this specific regression, have simulated it, and I think what we're doing is fine. We'll go back and revisit it with the math you wrote down. But basically what we find is something that looks a lot or even stronger than the panel regression, right? There could be various reasons for that. Maybe there's more signal in a long trend, right? You beat down some of the noise, and so maybe there's less attenuation, right? There's reasons those things could be different, but at least to a first order, that suggests that that the short run stuff seems to be getting it sort of right in terms of how people respond to the slower moving stuff, just empirically. Maybe those are coincidentally the same, I don't know, but at any rate, when we do this in the US agricultural setting, when we do it in subnational GDP around the world, we see long differences estimates that look pretty close.
Great. Maybe one last question from anyone? Marshall, if you want to take 1 minute to respond to Paulina, and then we'll stop here, okay?
Sure. Thanks. Yeah, the spatial spillover stuff is really important. We have a real, as you saw in the paper, I didn't show it. We have a hacky way of doing it, just using sort of spatial lags in the paper, and it seems like stuff goes through. Still trying to figure out exactly the right way to run that. That's unbiased, but it's a totally legit comment. On the state by year FE, yeah, let me just say that we can run it with less restrictive time FE, and everything is pretty stable. The reason we run it is if you actually look at the data, you have state-specific trends that look very different across states. So even if you look in the US, like North Dakota has these insane like local GDP growth effects, right, that happen around fracking, and you don't see that in Ohio, right? And so those trends are in the data. Whether or not we actually need to fit them for identification, I think is a reasonable point. And maybe we can claw back some variation if we're not so aggressive on the time control. So appreciate that point. Thanks.
Great, thank you so much, and sorry again for being late today. This was a lot of different papers, a lot of different methodologies, a lot of different results as well, but we're all learning here. So thank you so much to everyone, and I hope to see you again at different conferences or new conferences on climate change. Thank you. And I want to thank the World Bank as well, the different department at World Bank for allowing this conference to take place. Thank you.